Okay, good afternoon, guys. You will see how to use the tool and some of its key configuration. Today I'm going to introduce you a very handy operating and maintenance toolkit that developed by xFusion, FusionServer Tools, tools for sure. So basically, FusionServer Tools contain tools required for operations such as batch development, maintenance, and upgrade of servers. It helps the server management and the maintenance personnel perform press operations on devices during the presetting process, reducing operation difficulties and improving work efficiency. From IP initialization configuration, OS development, firmware driver upgrade, and spare part replacement, FusionServer Tools provide all functions required for O&M in the life cycle of computing products. So FusionServer as a platform for server operation and maintenance. Oh, by the way, operation and maintenance in hereinafter referred to as the O&M. Through FusionServer Tools, we can option various functions required for server O&M and process. These functions are carried in the form of plugins. I'm going to introduce this tool to you from the following aspects. First, we can perform some deployment operations such as basic configuration, BMC configuration, OS deployment, and IP configuration. Second, for example, a health check during device running, part control like power on and off, and log collection. Finally, the upgrade operation. All of those are the mainstream operation of these modules. Before we perform the batch deployment on FusionServer Tools, let me show you a few fascinating characteristics of FusionServer Tools. One-stop deployment, FusionServer Tool will support all of our server products. The tools used in the whole life cycle of server operation and maintenance, including initial upgrade and operation and maintenance, will be integrated into it, which is called one-stop. All the manpower used throughout the life cycle can be integrated and implemented through this platform. The most important is it integrated in the form of plugins, and you can upgrade the plugin through some import and the removal of the plugin. Platform-based, plugin-based, and extensible. Mainstream versions of our platform and plugins are basically independent of each other in most scenarios, right? Like, for example, after the plugin upgraded, the platform does not need to be upgraded. You only need to upgrade a single plugin. In addition, when I add a device now, I want to add a new plugin such as health check or upgrade, enter function management, then download the plugin import. Can directly enter the new function and start the operation. Do not need to restart FusionServer Tools to take effect immediately. About Wizard, of course, for users, wizarding undoubtedly reduce their learning costs, right? Batch-based, the performance of the tool has been optimized before. Currently, the tool can handle hundreds of server operations by one engineer. Then there's Lightweight, which can be easily installed on compute engineers' notebooks and relatively low resource consumption. Tools are only a few hundred megabytes in size, while plugins are only a few dozen megabytes. This part may continue to be optimized in the future. Now I'm going to show you, and this is a panoramic view of our tools. This includes not only FusionServer Tools, but also some of its related components. This part is our FusionServer Tools, and the bottom part is some hardware supported by FusionServer Tools, such as V3 to V6 and future V8. We will provide support for this hardware. There are some hardware, such as read card, NIC, hard disk, and media. And then these parts are some of the capabilities of our single node systems. The tool can perform operations such as OS configuration and RAID configuration through the onboard BMC. Smart provisioning provides an onboard mirroring system for servers. Some of the capabilities we provide through SPs are OS deployment. In addition, firmware upgrades are often used on the live network in the future. The onboard smart provisioning is recommended to upgrade the PCIe card. the upgrade efficiency and upgrade stability of the PCIe card is relatively high because one step of mounting an image is missing. The dependence on the network speed network is reduced. These parts the main capabilities of FusionServer Tools, which are divided into 5 modules. Each module has different functions to cover server deployment and O&M. Let's briefly look at a function of each module. First, this is the deployment configuration, aka deployment delivery. So basic deployment configuration such as IP address configuration, NTP configuration, and alarm related configuration are included. The second is upgrade change. When some firmware of service needs to be upgraded, it can be upgraded through the functions in the upgrade change. FusionServer Tools currently has 2 tools for upgrading. One is firmware upgrading and the other is one-stop upgrading. In the future, the focus of research and development may be on one-stop upgrade, and firmware upgrade will fade it out slowly. Then there is a mass distribution. The tool of batch distribution is mainly used for some customized operation and maintenance task. Maybe the tool does not support some functions at present. For example, if I want to execute a command in batch and view some information on the device in batch, we can issue commands in batch through the tools of batch distribution. It supports issuing various commands on the device. That is, I can issue commands to the device as long as the device supports them. Like if my 100 devices needs to issue one or more commands, I can implement them through batch distribution. Then there is the upgrade evaluation. There are also device changes. Device changes are implemented by attaching an image. For example, we can execute some customized scripts by attaching the script together with the image and then executing the changes. Then, in addition to the upgrade and change, it is our routine maintenance. The function in the routine maintenance module are also used frequently. Health check is divided into an out-of-band check and in-band check. Out-of-band inspection is mainly throughout access to the BMC interface to obtain the health information of the device and finally generate a report. Currently, in-band mainly support Linux system connected to the Linux system and check the health status of the device by executing some items of our tools. Power control is what we just said. For example, it may be necessary to do a batch of power on and off for the equipment at some time. It refers to batch rest, power off, power on, and other operations for the IBMC system. We can use this tool to perform batch operations. The configuration check tool is mainly used when we distribute some configurations to this device at the beginning of delivery. I want to see whether these configurations are successfully distributed. I can simply check whether the configuration on each device is the configuration we expect. The last is troubleshooting. This section includes an in-band and out-of-band log collection. When a failure occurs, we can collect the device log for further analysis. Then this one modifies the electronic tag, which is in the part of replacement. The current menus may be that after we change the mainboard. We may need to change its SN or other information to the previously mainboard. For example, after I change the mainboard, the SN of my previous mainboard is A, and it is sure that A is SN instead of A. I may need to change it back, and I can use this tool to change the electronic label. Then copy machine is mainly used to diagnose equipment such as hard disk. Log diagnosis is a tool that we just launched recently. At presently, it is mainly used for fault diagnosis of failed components. This whole part is the main prospect of our current tools. Let's talk about the operation process of FusionServer near and operation and maintenance. When we decided to do an operation maintenance task, The general process is to first upgrade our tools to the last version and then prepare relevant materials. For example, if you want to upgrade, you should prepare the corresponding driver firmware. The last step to understand the operation instruction of tools. As for the last version of the upgrade tool, it is generally necessary to upgrade related plugins. However, if the FusionServer Tools platform has not been upgraded for a long time, it is also recommended to upgrade it. After these are prepared, enter the site to obtain the authorization of the customer. If some operations need to stop business, such as upgrading BIOS, you may need to stop business first and stop business after backing up data before adding devices. Then configure our tools and distribute them through them. After these tasks are completed, we can restore the business. In fact, the opening is mainly that after the hardware equipment has been mobilized and installed, the software needs to be configured or the FusionServer tools will be used for in-band and out-of-band deployment. After completing our tool introduction, let's begin to introduce the internal operation and the development of the tools. This part, okay? Alright, first click the link to enter the official website of xFusion. Now you can see the home page of official website and find the technical support. Please log in to the website with an engineer account to download the required files. Place the cursor on technical support and a list will pop up. Find FusionServer Tools and click to enter. Under the software option, you will see the installation package and plugin package for installing FusionServer Tools. This is the installation package for running the software. These are the basic plugin packages. Some plugin package has different versions. You need to download the corresponding plugin packages according to the engineer's computer system. Place the installation package and the plugin package in the same directory for subsequent search. Double-click FusionServer Tools.exe file to run the installation program. Next, and accept the license. Select the path of the files you want to install and then select the installation role. Install and finish it. After installation, run FusionServer Tools, which is the main interface of the tools. The number of the device currently added will be displayed in the upper left corner. You can now see that some functions are available, but some functions are unavailable. The reason is that these functions require us to manually add plugin packages. The standalone function management can enter the management interface. Select not installed and you can see that the plugins is not installed. For standalone import, select the corresponding plugins package in the directory and then click OK. Oh yes, you can also import installation packages in batches. Some plugin package cannot be found on the download page just now, so we will be prompted which software we need to download, such as the log diagnosis function. For the missing plugin package, search the plugin package on the official website, find the plugin package and download it so that the log diagnosis function can be opened through the function management function. Next is the same as just now. Next, add the device to the FusionServer Tools and click Add Service Device. First, make sure that your computer can access the device to be added. In fact, we have two ways to add devices. One is manually enter device-related information in the tools to add devices. If only one device is added to the device, the starting IP address and the ending IP address should be the same. If devices with the same multiple IP address are added, starting IP device and ending IP device should be filled in the IP address. For multiple discontinuous IP address or multiple identical IP devices, I will explain the relevant solutions later. Click OK after using the method to add the device. Another method to add a device is batch import. Engineers can obtain templates from the get templates file basis. This template has two subtables. The H information, this part is for the E9000 devices, so let's talk about the first table. Items marked with item be marked is required, and the following option can be filed according to the project requirements. After form is completed, the form is imported and the equipment is added. After adding, you can see the number of servers we added in the main interface. Just now, we mentioned that if there are multiple identical IP devices, right? So they cannot be added in batches. So we need to modify the IP address of the devices first. Therefore, if there are multiple identical IP address, we need to modify the IP address of the device through the IP configuration function. Other function of the FusionServer Tools needs to add a device first, but the IP configuration does not. There are two methods of IP configuration. The first is through IBMC or SN configuration here, and the other is through IP configuration. You can choose to click add a form filling information below for configuration or import the configuration table. If there is no template, you can download the form template. This is the IP configuration table. When configuration type is set to by IP address, the IPv4 or IPv6 address is mandatory. When configuration type is set to config by MAC or SN, either the SN or MAC address is mandatory. The username and password are mandatory. At least one of the IPv4 mod, IPv6 mod, and host name must be set. IPv4 and IPv6 mod can be set to static or DHCP. If the IPv4 mod is static, set the IPv4 address and the subnet mask. If the IPv6 mod is static, set the IPv6 address and the prefix. If the IP mod is set to DHCP, you do not need to set IP address, mask, prefix, or gateway. This is the relevant information used in the IP configuration. We can query it on the IBMC interface. After completing the above configuration, we begin to deploy OS in batches. Before deploying the OS, make sure that first, the OS deployment function can be used normally. Second, if you need to upgrade through the smart provisioning, please ensure that the smart provisioning is in the last version. Third, make sure that there are two empty hard disks in the device to form RAID 1 to store the operating system separately. Fourth, prepare the operating system mirroring file. Enter the OS deployment interface, choosing the device. Start OS deployment after adding device. First, wait for the tool to confirm the concurrent number. Wait for the tool to scan the server, confirm the status and the progress, and then click Set Parameters to start OS configuration. We have two deployment methods to choose from. One is through smart provisioning, and the other is to directly mount the image file for OS deployment. As I said at the beginning, if the engineer chooses to deploy OS through smart provisioning, make sure that the SP is the last version. When selecting the image file to mount, make sure it matches the selected OS version. Set the administrator account and administrator password. Other options can be configured according to your needs. After configuration, click Deploy OS and confirm the risk before deployment. Wait for the completion and the above interface will indicate successful deployment. I focused on the OS deployment and the IP configuration in this part of site deployment delivery. Now I will explain the remaining two parts, namely hardware configuration and server deployment. If almost all content needs to be configured, I recommend one-click configuration. In hardware configuration, each part is configured separately to save time. If a content is configured separately, the tool cannot scan and retrieve other content. In one-click configuration, wait for the completion of concurrent number and status and click Set Parameters to start one-click configuration. Here we can see that we can configure IBMC, BIOS, and RAID here. It is recommended to restart the server after checking the configuration. Because many configurations need to restart the server to take effect, please ensure that the server data is in a safe state. Waiting for the tool to obtain the device information and start the configuration. This is one-click configuration. After checking the required configuration, the tool will automatically configure it for you. The other is manual configuration, where you can configure manually. Next is the BIOS configuration, which is the same as above. Finally, RAID configuration. There are some precautions for RAID configuration. Batch configuration requires service for the same model. It is recommended to configure one server first, and then perform batch configuration after there are no problems. If the number of servers in batch operation exceeds 200, it is recommended to operate 100 servers first, and then perform more than 200 servers in batch after success. Running FusionServer Tools on different maintenance terminals to operate the same device at the same time is not supported. Configuring RAID will lose the original data of the hard disk. Please check out the data in the hard disk before configuration. The RAID card models selected for batch configuration must be the same. The IBMC version of the server is required to be 2.32 or above, or v3.0.1.0.0 or above. The server must be powered on for RAID configuration. The server must support the Redfish interface for RAID configuration. RAID card must support out-of-band management for RAID configuration. Please make sure that the selected physical disk ID exists on the device. Add logical disk to the existing disk array. Select empty in the drop-down list for RAID level and number for member disk. The second level cache can only be set if the selected physical disk has an SSD. Support the number of RAID groups and the maximum number of logical disks created number a single RAID group. Confirm risk confirmation. Complete deployment. This server deployment. The difference between it and hardware configuration is that it's an OS deployment function. The reason is that OS deployments take too much time. Then we do not need OS deployment. We can use hardware configuration to achieve our goal and save time. The next part is routine maintenance and troubleshooting. The function of these parts are relatively simple, and I will briefly explain the important parts. First is the health check. The health check tool is a tool that can be used to customize policies, check devices, and export detailed results about operating status of device. The inspection tool is designed according to the wizard-based operation process. The exported inspection reports are displayed in graphics, which makes the report easy to read. It provides the batch device inspection function, displays virtual health check reports, and monitors the device running status in real time. Before using the tool, you need to perform the following operations to ensure that the tool can be used properly. Ensure that a PC is properly communicating with IBMCs or target servers. The SNMP, IPMI, SSH, and HTTPS communication ports are enabled, and the server IBMC IP address can be pinged from the local PC. Ensure that a PC is properly communicating with the HMMS and CMCS of target servers. The SNMP and SSH communication port are enabled, and the server HMM and CMC IP address can be pinged from the local PC. Ensure that the PC is connected to the OS to be inspected. The OS IP address can be pinged, and the SSH and SFTP communication ports are connected. Check whether the servers or OS are compatible. You need to prepare some data for server inspection, IP address of the server, IBMC and HMM or CMC management network port, username and password for logging into the server. You need to prepare the data for OS like OS IP address, OS username and password, right? Next one is power control. Power control provides the device power control function and support operations including resetting IBMCs in batches, powering on and off the system, and restarting the system. Ensure that a PC is properly communicating with IBMCs of target service. The SNMP, IPMI, SSH, and HTTPS communication ports are enabled, and the server IBMC IP address can be pinged from the local PC. Ensure that the required protocols and ports are configured for the IBMCS. And you need to obtain some data to IP address of the IBMC management network port on the server IBMC username and password. Next is configuration check. It can check the IBMC BIOS and RAID configurations of servers in batches. And the requirement is basically like health check and power control. So I just passed this part. The log collection tool is a tool used to collect server log in one-click mode. It supports batch collection and progress display. It can support the one-click batch collection of server hardware and OS log information. And this part is very easy, but there's still some caution you need to know. Before using the tool, introduce the tool to the customer, right? Ensure that all maintains operation authorized by the customer. Operations without the customer's approval are prohibited. Do not transfer fault locating data out of the customer's network without the customer's approval. Comply with the local laws and regulations when using the tool. After faults, delete local log files. Before using the tool, you are advised to back up key data. The last one is upgrade and patch installation. Server bound upgrade sets upgrade policies for servers to upgrade IBMC, BIOS, CPLD, CDR, retimer, network card, read card, and hard disk firmware all at one time. You can upgrade devices of different models at the same time. However, you need to set the upgrade policy for each model separately. The bundle upgrade function allows you to configure an independent upgrade policy for each servers or configure the same upgrade policy for multiple servers. In the concurrency text box, set the number of servers that can be operated in batches at the same time. The value ranges from 1 to 150. The default value is the middle value of the CPU test the concurrency capability. CPU concurrency capability indicate the recommended maximum number of concurrent CPUs based on the CPU performance test. The test result is related to the CPU usage. The test duration is 10 seconds. You can click querying information to query the information about select device, which can be the upgrade policy is not set, not supported, execution failed, partial execution was successful, the execution was successful, or unknown. Select the firmware package to be upgraded. Save the firmware package and the corresponding signature file to the same local folder, and remove all the files that are not related to this upgrade. Click Browse, select a folder where the local firmware packages are stored, and import all the appropriate firmware package in the folder. Import firmware package. Click Next. The Select Target Version page is displayed, and click Next. The strategy confirmation page is displayed. then finish configuration. This is batch distribution. Batch distribution is a tool used to install IBMA and iDriver. As you can see, you need to select the corresponding installation package. For example, you can import the installation package prepared by you to install and upgrade. Remember to modify the corresponding file location code after importing the installation package. This part is relatively small and simple, so I will simply carry it. This is the firmware upgrade. Firmware upgrade support the batch upgrade for the server IBMC, BIOS, CDR, retimer, CBLD, and smart provisioning firmware. It's basically like server bundle upgrade, right? Just a more smart provisioning. There are three parts in firmware upgrade: single part upgrading server firmware, multi-part upgrading server firmware, and upgrading smart provisioning. Select the upgrade method after obtaining the device information. In the Upgrade Firmware tab, click Select the local upgrade package. Ensure that the IBMC version, BIOS version, and the CPLD version match each other in the same server software version list. The upgrade policy evaluation page is displayed. Select the device whose upgrade policy needs to be evaluated. Click Evaluation. The evaluation results is displayed in the evaluation result column. When you upgrade the BIOS, CPLD, CDR, or retimer, dialog box is displayed stating the firmware task effect only after the device is restarted. Please select. If you select only load the firmware, you can restart the device later. The CPLD upgrade requires the device to be powered off and then powered on. And you also want to upgrade the CPLD, power off and the power on the CPLD. For other modules, restart the server for the upgrade to take effect. If you select safely power off and then power on the device, service will be interrupted. The server restarts immediately. Click OK to continue the upgrade, otherwise click Cancel. If you choose to continue the upgrade, a dialog box is displayed stating if IBMC version is earlier than 2.56, reset the IBMC to release memory placed before the upgrade. Are you sure you want to continue? If you confirm that IBMC version is not earlier than 2.56 or the IBMC can be restarted on the device, enter yes in the text box and click yes to continue to the upgrade, otherwise click no. When you upgrade the IBMC, a dialog box is displayed stating to ensure that the active and standby IBMC version are the same. Click upgrade again after the upgrade is complete. If the process reached 100%, the upgrade is successful. Alright, the above is the main content of mass development using FusionServer Tools. Now we have learned the deployment by single node and batch. The server is ready to hand over to our customer. Okay, thank you guys, and that is all of my part.